name is Megan Finney, and I am here today to interview the AI VVO team about their upcoming project. So my first question is for the CFO, Rachel. My question for you is, what are you building and what is the plan for design?
Hi, my name is Rachel Owens, and I'm working on the AI VVO project. We are designing and will be implementing a cloud-based machine learning algorithm for volt-var optimization for distributed energy resources. This project is intended to increase voltage stability and reduce energy loss. We will also be designing and deploying a web-based dashboard to visualize data plots and analytics. This will allow the user to navigate the application, set voltage levels, and select a specific machine learning algorithm to run. The system will be used by workers managing distributed energy resource grids to help improve the grid's quality, and it can be used for the Iowa State lab students and utility operators. Volt-var control is a process of managing voltage levels and reactive power throughout a distributed energy resource grid, and a volt-var optimization is a tool that can dynamically adjust the distribution system to reduce system losses. Using machine learning to improve these processes will help improve voltage profiles for end-use customers, people like you and me that use Ames energy resources every day. By minimizing losses and waste for power companies, this application can help utility companies save money and, by extension, their customers.
Thanks, Rachel, on answering that question. So my next question is for the CEO, Jaden. And my question for you is, what impact do you think your project will have?
Hi, I'm Jaden Alumcia, and I'm the CEO of the AI VVO project. This project's goal is to reduce the impact of energy loss. In doing so, the project will have an impact on the economy, the environment, and everyone who benefits from a more stable and reliable power output. We would like to see energy loss come down, and with it, bring a smaller environmental impact from power distribution grids. This increase in the efficiency of our power distribution grids would allow us to waste less resources that could be put to use elsewhere. Economically, this project will bring down the cost of power, as less power will be wasted during distribution. This will allow power companies to save much more money. This brings us to the most important thing impacted by this project: you. You will see your energy bill drop as the power companies don't lose as much money during distribution. You will see less power outages and blackouts as the power output is more reliable. And you can rest easy knowing that we are working towards more planet-friendly options when it comes to resource management and usage.
Thanks, Jaden. My final question is for the CTO, Demetrius, which is, what technical challenge do you foresee in the future of this project?
Hello, I'm Demetrius Christou, CTO of AI VVO. Currently, there are many technical challenges that our team will be facing this semester. Currently, we have inherited a new project, so there's a lot of existing code already and an existing project for us to build off of. So to show some of the technical challenges that we have to solve, I will quickly go through the old project. So this first screenshot is a picture of the settings screen, and on this one you can change around and mess around with some of the settings before you actually start the simulation of the grid. Since we're making a lot of changes to the machine learning algorithm itself, which is what simulates the grid, we may have to make some changes to this settings page as the algorithm itself changes. On this screen you can see that this is the output page, and it is not the easiest thing to decipher. The data is kind of everywhere and it's hard to read, so one of the things that our team has to solve as well is to make this data look much more presentable and easier to understand. In this final screenshot, this shows the grid overlay of the electrical grid, and it's shown by all these nodes connecting to each other in a graph formation. In the application itself, you could click on each of these green nodes and see some more information about them. But for our team, what we're trying to do is make it to where you can overlay these nodes onto a Google Maps kind of map where you can clearly see like where the electrical grid connects on a real map of the area. Overall, that's pretty much all our major technical challenges this semester.
Thanks, Demetrius. Take this time to thank the entire AI VVO team for hopping on today to answer some of my questions. Thank you, everyone.